Hello, everyone. I'm going to talk about workflow automation with continuous integration and continuous deployment. And I assume that not everyone is familiar with all of these terms. But essentially, I'm going to talk about a kind of workflow. A workflow refers to a number of steps of things that you do, whether you are writing a paper or you are writing your computer code or script or whatever creation process you may have in terms of files or text files. And a lot of times when we do these kind of things, some of the things will require, say, human intelligence, right? You are thinking your thoughts into the writing process, whether it's your paper or your code. But then there are other parts that are quite tedious and mundane. For example, you have to convert your text file into web pages, for example. And that process is pretty mechanical, and you don't want to spend your time doing that again and again. And so this automation refers to replacing those kind of mundane or tedious work or workflows by assistance from computers. And that process in software engineering or software development, they are called continuous integration and continuous deployment. And I'm going to explain this in practical terms in the next few slides. So essentially, I'm going to talk about how to kind of set it up to assist your day-to-day work. And also, I'm going to talk about the relations to version control, because these two things actually work together pretty well. And so there's a natural coupling between these two sets of tools. And then I'm going to talk about, by looking at the practical examples, I'm going to look at the basic elements of CD and CI. And then we will look at kind of in practice, how do you actually do it? And for that, there are multiple kind of free services we can take advantage of today. And there are more than 3, but then I'm going to talk about all these 3. One is called GitHub Actions. So GitHub is one of the popular, say, website or web services for hosting your repositories. A repository is basically a set of files. For example, your thesis, your dissertation files, or the files of one of your projects. And if you are not already using Git, I would highly recommend look into it. If you are in the early career of your grad student study, this will help you in the long way. If you are already a kind of established researchers, this will still help you on a day-to-day basis. And the second one I'm going to briefly talk about is GitLab. So GitLab is one of the similar services, similar to GitHub, but it has a slightly different web interface. But you can just think of as another GitHub service. It's also free, and you can do a lot of things on this website. The third one I'm going to talk about is called Travis CI. So in the CI and CD world, although we have not exactly defined what these are, Travis CI was one of the early services that a lot of people use. And after Travis became quite successful in terms of providing a CD CI to help automate a lot of people's workflows, GitLab and GitHub, they also offer their CD CI kind of services. And so these days, a lot of things have moved onto GitHub and GitLab. But Travis CI, since they came out early, it is still very popular. And I'm going to kind of talk about this because some people still do things on Travis CI. And at this point, it may not be clear to you that how any of this work, but then we will walk through simple examples, and hopefully you will get some understanding. And so what exactly is CI? So I'm going to use the term CD and CI in all of the following slides. And for the working definition of a CI, it is one of the software engineering technique in a process of developing the software or writing a paper. From time to time, you are going to make a lot of changes. And this continuous integration refers to you frequently merge your changes into your work. For example, if you are writing a paper with 2 other people and you are making changes to section 1 a few times today and a few times tomorrow, the other person, your co-authors, may be also writing on section 2, or maybe the co-author is also working on section 1 with you, and the co-author is going to make additional changes to the text. And so from time to time, you are going to kind of merge your changes and his or her changes into your writing. And continuous integration refers to you very frequently, and I'm going to talk about what frequently means. You frequently merge or checks the correctness of the final product. So the idea is that whenever you make a change or the co-author make a change, then you want to make sure that that change can be successfully merged into your final paper, right? And when I say successful, it means not only there's no conflict, but also the format, or other thing, whatever you want to check is successfully merged. And so the word continuous refers to this frequent merge. And integration means just integrate into your work. Right? So that's essentially what CI means. Continuous deployment followed a similar idea. So continuous also means frequent. Deployment, so the origin of this comes from software delivery, right? So if you're a software company, you write a program and you want to kind of ship your program to your customer. So that refers that's called deployment or delivery. And so, but in our kind of university research environment, you can think of your delivery or deployment as your whatever product you are creating, right? Your paper, your program, your data set, right? And so continuous delivery means every time you make a change, kind of similar to CI, every time you make a change, you make it ready for the product to be delivered, right? So basically you always make sure that whatever change you make, the thing is everything is tied together and ready to go. So that refers to a continuous deployment. So in this talk, we are going to use the loose definition of CD and CI. So think of them as some of your data set, program, papers, whatever computer product. And then we are going to look at how to automate some of the creation process. And the word frequent is quite important in a sense that instead of doing this frequently, in the old way of doing this is do this once in a while, right? When you are writing a paper with the co-authors, and because the process of merging the changes is quite tedious, and people kind of put it off by saying that, okay, we will do this like every 3 days. Every 3 days, we are going to review the changes. And then, so we do this once in a while. And this is not the same as continuous integration, and continuous deployment refers to every time you have a change, then you make sure that that change can be merged, right? So there's a difference in terms of the frequencies. And we will also talk about how frequent is frequent enough in the later slides. So if you consider in terms of version control, we call this commit, merge, test workflow. And again, think this loosely in terms of you are writing a paper, for example. So the horizontal axis here, this is the main branch or the main document, for example, you are writing. And also this also represents the time, right? So over time, you are going to make changes, and changes are denoted by C1, change 1, change 2, change 3. And in terms of version control, if you're running a version control system, normally they are called the commits. So when you make a change, when you save a change, and you want to kind of check in the change into your version control system, like Git, that is commit 1, commit 2, and so on. So if you look at the axis here, in terms from the viewpoint of your main, say your paper, every time there is a commit, right? the state of your paper, for example, here, is different from the state before, right? There's some words have been changed and so on. So when something is changed, you want to make sure that that change is valid. Valid in the sense that valid can be have different can be valid in different ways. For example, it is a valid. For example, you are writing a paper in LaTeX. For example, all of your syntax needs to be correct. Right? It can be the compilation cannot fail. Or if you are writing in certain way of formatting your data sets, the format needs to be validated, for example, by other programs. Right? The program needs to be able to read your data sets. So if you messed up your data set format, maybe some program will fail to read. And that testing can be done when something is changed, right? So at all of these red dots here over the course of the development of either your paper or your program, on the red dots, these are the time points when the main product needs to be validated or tested or checked, right? So the idea of continuous integration means that you want to perform the same kind of testing or checking process at all these red dots. And so that means that every time you have a change, I want to check the whole thing again, right? Make sure that everything is good. And so we want to do this often. Often means that you do it every time when there is a change. And of course, doing this, human is not designed to do this kind of tedious work. So you want to do this automatically, right? You set up some system to this automatically. And in principle, you can set it up all this automation on your own laptop. You don't have to use any of the services I'm going to talk about later in this talk. But those services, those web services, in addition to their nice web interface, user-friendly, they can actually replace a lot of things. You don't have to reinvent the wheel to do this kind of testing. By using those web interface I'm going to talk about today, they can actually replace a lot of kind of manual work. And so in reality, especially when you are developing something with other people, you are not working alone. So co-authors of a paper, or you and your other people, your collaborators working on the same project, a lot of times you are making a branch, right? For example, you make some changes, but then at this point, the yellow line here, I call branch X1. So this is branch is in the version control terminology. For example, you're working on section 1, continuously working on section 1. One of your co-author wants to kind of branch off the work and to work on another section, so that you can work on the same kind of project in parallel, right? But parallel means that you are working on two different branches of your document, so that there is no conflict during the parallel work. But at some point, you want to merge, or your co-author wants to merge that whatever change that he or she changes into the main document. And so this frequent check-in can also be applied on the separate branch. For example, your main branch is being checked every time there's a change. On the separate branch, that can be also be checked. And of course, when that thing is merged into the main branch, the whole thing can be checked again. Right? So checking or testing can be applied at any stage of this, whenever a change has occurred. So that is the kind of the main idea of continuous integration. Right? So every time there's a change, you want to run a check. And now the remaining question is, how do you set up the running the check part, right? So we now understand that there's an advantage of doing this. And some people don't like this kind of tedious setup, and just the argument is that we can just do this once in a while. But then I think the past experiences have shown that if you do this once in a while, sometimes if there's a problem at some point, since you don't do this often enough, it's kind of hard to identify what went wrong at some point. Right? You have to kind of go back and find out which one went wrong. But if you do the continuous integration approach, then it's quite easy to, whenever you see an error, you know that that is the immediate commit that caused the problem. Because something is successful here, something failed here, then this is the one that is causing the problem. And so again, just think of this as, say, writing a paper or writing your script or preparing your data sets. And like I mentioned earlier, continuous integration, continuous deployment, CD and CI, they work naturally with a version control system, right? Because when I say when there is a change, and normally that change is defined because version control system is designed to track changes. So when there's a change, that means that there is a change of state in the version control system. And that change of state can be the trigger to trigger the CD and CI check-in process. And so naturally, your work needs to be under the control of a version control system, right? So that you can use the trigger to launch the CD and CI processes. And so two popular kind of free Git repository hosting services, GitHub and GitLab. And I don't know how many people are not using this in this audience, but if you have not started using this, I would strongly recommend looking into this. You can actually benefit quite a bit by having the habit of checking your work into a version control systems. And the use of these systems are free, and they have free account, free plan. You don't have to pay anything. You just need an email address to sign in. But if you use your UCLA email address to sign in, they actually can upgrade your plan for free if you use your university email address. So you can actually get the kind of professional plan without paying. Another thing I want to mention is that, so version control system Git, the command line interface is quite powerful. And this talk is not about a version control system, but I want to mention it that some people are kind of scared away by the command line interface, although it's very powerful. And there is a product called GitHub Desktop. So this is a little GUI interface application that can run on Mac and Windows. And this is actually quite convenient to use. So if you are thinking of using Git, or if you feel Git is too kind of tedious or too difficult to use, I would recommend trying out the GitHub Desktop, right? You can easily work with the Git system using this kind of menu, drop-down menu system. But if you use a GUI editor, like a VS Code editor, it has a built-in Git support, right? So you don't have to deal with the command line interface. So just want to mention that. Or if you are comfortable with command line, just run the command line. So let's consider this example. And this is similar to the CDCI ideas. Let's say that you are creating your personal website, right? So these days it's kind of cool to have your own personal professional website. So where you want to put your CV or your publication or some interesting plots from your research. So when you're creating a website, the website suppose is written by a bunch of source files, the text files. And then, of course, since it's a bunch of files, it's natural to maintain your files using a version control system like Git. And over time, your website, you want to update your publication list, you want to update certain information about yourself, you are going to make a change, right? So you're making changes to the text files of your website. Of course, like I said, when you make a change, if you have the CDCI set up, that process will be triggered by your commit, right? So that commit process will basically clone your files to another place because you don't want to, for example, test or build your website in place because that may mess up your original files. So basically copy this away to some other place. And these days, the way to do this is by copying this to some virtual machine or container, which is a separate isolated place, you do the rebuild. You do whatever testing rebuild you want. And once you make sure everything is okay, then you push the final product or your website to some web server, right? So if you are good at computer programming, you know, oh, I can do all of this by myself, right? If you write some simple script, you can automate this process, right? But the point of the rest of the talk is to trying to convince you that you can actually do this directly on GitHub or GitLab or websites, right? You don't have to maintain the automation script on your computer. And one big advantage of doing this on a kind of remote website is that you can move from one computer to the other, and you still have access to the same remote website. So you can buy a new computer without worrying about transferring your file from one computer to the other, because your site, your CD, CI, or all of your repository are still on the GitHub website. So the point of the rest of the talk is to talk about this kind of process, right? So you make a change and trigger a bunch of actions, and then we are going to automate all of these actions by using the CD/CI kind of mechanism built in the GitHub or GitLab, those websites. And so if we look closely to this process, you will see that these initial steps, they require human intelligence or human intervention, right? When we say make a change, this means that you have to put in your thoughts. So make a change means make a change to a file. So this requires your thinking, your other consideration. For example, this change, maybe you are making a change to your program. So you may have to run through a lot of brain power to determine the change. And also commit also cannot be automated, because you have to be, a human needs to determine that whether that is good to go into the version control system, right? So these two steps require human. But then the rest of the steps, these are pretty mechanical and tedious. The whole step, so clone the source, rebuild, testing, and push, all of these things can be automated, right? And so we are going to kind of see how to set it up in GitHub and GitLab. And so when I say a change, in the previous examples, I always talk about a commit or push to make a change to a document. But in the broader sense, or in terms of the CD and CI processes, a change can also refer to some kind of pull request, issue creation, or new release. If you are not familiar with these terms, that is okay. Basically, these are all kind of related operation in terms of making changes to a system that is maintained by version control. A pull request refers to that maybe your collaborators look at your, say, document or your programs on GitHub, and the collaborators wants to make a recommended change to your document. So a normal way is that you give your collaborators permission to commit to your Git repository, right, or version control repository. But a nicer way to do this is by creating a pull request. So I don't want to go into the details because this belongs to the topics of version control, but I want to kind of broadly mention that all of these are under the category of change. So when any of this happens, they can trigger the CD and CI process. So in the next few slides, we are going to look at the actual examples. So I talk a lot about version control and CD/CI. So now we want to see how to do this actually in actions. So to actually set up a simple CD and CI, we are going to look at the samples that I have already uploaded to GitHub. So if you, and all of these materials are will be made available to you if you want to kind of try it yourself. And I will send you the link to all of these materials after this talk. So to actually have a CD and CI, of course, you need to do this on GitHub. So you need to have a GitHub account. And also you need to have some kind of repository, right, to have something to play with. So if you want to actually try this, if you have never used CD and CI on GitHub, I'm assuming that you already have an account, you can actually clone my repository. This is a public repository. So if you go to this link, you don't have to do this now. You can do it after the presentation. There are a lot of kind of tabs. And then if you don't know how to clone or make a copy of my repository, you can just click on this fork icon. So fork refers to, it will make a copy of my repository into your GitHub account. And during the process, you will have a chance to enter the name of the repository and so on. So suppose that you do that, right? So you now have a copy of my repository, and you can now play with it. So to see this, once you go into that repository, and I'm going to show you in an actual browser, but since there are a lot of icons, I want to kind of point out where we want to look at. So when you look at the repository, you will see the name of the repository. And in your case, this will be your account name. And this is a kind of overview of the repository. And when a repository on GitHub is enabled to use a CD or CI, continuous integration, you must have a folder, and the folder has a special name, and the name is .github/workflows. So this is a folder, the two-level folder names. Your script to control the CD CI actions will be under this folder, right? And for this extremely simple repository, in addition to the CD CI folder, I only have this one file, right? So this is a README file. So this is how the README file is rendered on GitHub. It's a text file, but then this is in a markdown format so that some fonts are bigger than others. And what I want to point out is that when looking at this folder, this file has these two kind of weird looking icons. And this actually are showing the status of my CD and CI. We will come back to here. So this is kind of overview of how to look at the repository. The icon here is an icon called actions. So in github.com, their CD and CI are under this actions icon. So when we are going to set up, we want to kind of check the results of the CD CI runs, we're going to go to this action place, right? So three places. One is the workflow folder to contain the CD CI script. The other one is the status of the CD and CI. And then to check the CD CI status, we are going to go to the action part. So let me switch to the window to GitHub. So this is in my browser. And then this is the my demo site, right? So the one we have seen the screenshot. And so if we go into this folder, you see that I have only two files here. And let's go to the first file. So this is a file, and this is called the YAML file. So this format is called the YAML file, YAML, and the extension is YML. So YAML file is the format for the CD CI control. And actually, this is also the format for GitLab and Travis CI. In the GitHub YAML file format, you will see that from the kind of the file, you can kind of tell what it's doing. This is the name of the CD and CI job, right? And then this says that this is triggered when something is pushed into the repository. And the rest of the lines here define your jobs, the CDCI jobs, basically the whatever you want to run. So in this case, I only have one job. Right? So under jobs, you can have multiple. And in our later examples, we will have multiple jobs. In this example, I only have one job, and this is the name of the job. The name can be anything. You can name this XYZ or name this PQR, whatever name you like. Something you can identify because you are going to see this in the result page. This job says that, okay, when something is pushed to this repository, I'm going to launch this run. And this run is going to run on the Ubuntu Linux latest version of Ubuntu. Ubuntu is a Linux distribution, a popular Linux distribution that is widely used on, say, Amazon or Google Cloud, a lot of cloud platforms, and also on GitHub. We are going to use the Ubuntu Linux to run a test. And on this Ubuntu Linux system, I'm going to run a number of steps. So these are the steps that will run one by one in that order under this job. Right? So if you have multiple jobs, each job will have a number of steps to run through. And in this case, this is a trivial job. It doesn't really do anything meaningful, but I just want to demonstrate the kind of the action of CDCI. This job basically only print out a bunch of information, right? So echo means echo is a shell command because this is a Linux system, a shell command to print something on the screen. And so this one is basically you're printing out my GitHub event name. Event refers to this push, right? So this is what triggered this CD and CI. Of course, you know what's triggered. It's a push, but this is just to confirm that this is coming from the push. You can also print out the operating system name, and in this case, is Ubuntu Linux. And also you can use, so you can see this, we are going to talk about this later. So although you can write essentially arbitrary script in the CDCI, on GitHub, a lot of people have developed kind of templates to run certain CDCI actions, and they have been kind of extensively tested. So for those things that are well established, it is a good idea to use what people have developed. So you can simplify your script. So in this case, I'm going to run this something called checkout. So this is one of the established template. So basically to check out your repository. Remember that the CD and CI, if you remember the picture we have, make a copy or clone of your repository on a separate machine. And that separate machine is Ubuntu Linux here. Initially on that separate machine, it's empty. Right? So when you launch an empty machine, there's nothing. So you have to kind of make a copy of whatever this repository is to that machine. And that is done by this checkout script. You can write your script to do the checkout, but it's a good idea to use this because it's one line, right? And these people, professional or software developers, they maintain this. So you know that this is very robust to use. And after you make a copy of your script, now this virtual machine or this container has your content, and then you can use the content to do a lot of things. And in this case, I'm going to just list. LS is the listing the files. I'm going to just list my content. Right? I'm doing nothing here. But you can essentially, this is a place where whatever test you want to do against your files, you put the script here. And so, like I said, if you put the file here and nothing happens, because this is only triggered, the CI process is only triggered when something is pushed to the repository, right? And so, for example, let me open this tab here. So I'm still in the same repository, but I'm in the action tab here. So action means you are looking at you are looking at the results of your previous action logs, right? So right now, nothing is happening because I mean, these are from the previous runs. Nothing is happening. But if you go here, right, suppose I'm going to create a situation that I can trigger the CD and CI. And so, for example, suppose I'm editing my file, right? So I'm going to edit my file, and I don't want to make any meaningful changes. So let's say that I'm going to delete, or I'm going to add one more space, right? And I'm going to save the file. So and when I save, you will see that this, you see that these two pop up, because when I save the file, there is a commit to the repository, and then that commit triggers these two workflows, right? And we just saw there are two files here. This action demo 1 is this trivial one that I just show you, I just explained. But there is another one called run. And this run is action demo 2, right? So the name of the job. So if you look at the output window here, you will see that action demo 1, and this is from the previous run. This is the one that just happened. And you can identify this by looking at the commit hash code. If you go back to, I don't want to switch back and forth, but if you go back to the repository, you will see that this 1DCF760, this is the commit. See, this is the latest commit I just entered, right, by adding this empty line, right? So this is the commit. And this commit triggered this CDCI actions. And the CDCI action, if you click on the link, you will see that this is my job 1. And if you click on my job 1, you will see this is the log or the result of the CDCI. And this is kind of the result is kind of collapsed into this bullet points. But if you click on, for example, this step, I say list files in the repository, right? Remember that I run this ls command on my repository, and that repository has only its one file, readme file, right? So this is a trivial repository. I'm just showing that you can, whenever you make a commit, this whole thing will be triggered, right? And so if you have this set up, then you don't have to worry about the process, right? Whenever you just keep making changes to your content, and you are going to see the result of this if you want to check. And I want to make a point in terms of the jobs. So you can have, so under this GitHub workflow folder, you can have multiple files here, right? And each file represents one CDCI process. And you can have arbitrary ones here. And so and each one, for example, this run 1 will be triggered by a push. If I go to another file, the other run file, this is also triggered by push, right? But this is a different name. And also there's a different, this one is longer. It also print out a bunch of informations. And in this demo 2, you see that this particular one has two jobs, my job 1 and my job 2. Again, the names can be anything you like. On my job 1, I'm running on Ubuntu latest, which is like 20.04 version. On my job 2, I'm going to run on a different container, Ubuntu 18, right? So you see that not only you can have multiple different jobs, you can actually run on different operating system if you want, right? So all of this can be set up by using a syntax of this GitHub Actions YAML file format syntax. right? So if you understand the syntax, you can set it up and you can just forget about it, right? So forget about means every time you commit, the whole process will be run again and again without any mistakes. And so on these two different jobs, I'm just also printing out several information, including the CPU informations, because we can also discover what kind of CPUs is used by GitHub facilities, right? So, and another thing to notice is that when you have multiple jobs here, in this case, 2 jobs, the 2 jobs will run in parallel, right? And so that is something to keep in mind. Only within a job, the steps are run sequentially, right? But the 2 jobs, because the 2 jobs are considered independent from each other, so they can be run in parallel. And that is, you can see this by looking at the results. So in the action demo 2, you will see have 2 jobs, right? The first job is running on Ubuntu Linux system. And the second job is running on a different Ubuntu system, Ubuntu 18, right? And also remember that in the job we print out the CPU information and all that. These are not the typical thing you do in the CDCI, but I just want to, for the demo purposes, I want to print out a bunch of information. And you see that if you look closely, you see that this is a Xeon Platinum CPU. This is actually quite new CPU. And also you see that this is a Linux system, and you see this keyword Azure. So that is an indication that in the back end of GitHub facility, they are running on a Microsoft Azure cloud system. And also you can actually see the IP address of the machine. And so all of these are kind of public information, so you can kind of poke around to see this. But the main point is that you can define your jobs to run on the GitHub facilities, and this will guarantee to happen when you make a new commit, right? So that's the kind of the first main idea I want to talk about, right? And when I talk about this README file, I also pointed out that there are 2 kind of, these are called the badges, right? So it's kind of colorful icon here. And you see that this is action demo 1. This is the name of my CDCI job. This is my action demo 2, the other one. Right? We have 2 jobs. And you see that this is a word passing here. So if you look at this file, oh, sorry. If you go back here, so those 2 icons are actually coming from this link. So this points to a particular link. So this is a badge for run 1 YAML. Remember, we have 2 files under GitHub workflows. One is run 1, one is run. And the run 1 corresponds to this demo 1, and it's passing, right? So if something failed, it will not show passing here, it will show failed. And so this is an easy way to show that if you just take a quick look at this, you see passing that you know everything is fine, right? You can keep committing your thing to the system as long as they are showing the passing, right? And if your co-author commit something to the system and this become failed, then you know something is wrong. So that is kind of the first demo. The first demo I want to talk about. So that's kind of the basic idea how to set it up, right? So if you once you have the slides, you will have all of these annotated slides to show where to look for things. So like I said, 2 jobs, right? You click on each one, it will show you which file this job refers to, and then you can check the output. And this is for the job number 2, and then it's point to a different YAML file, and depending on which commit it runs, you can check the logs, right? And so I'm going to, since we have already talked about this, I'm going to skip all of this screenshots. And one thing I want to point out is that, remember that we talk about using this existing checkout script that other people have developed. And checkout is one of the common actions, right? So for almost any kind of GitHub CDCI or GitHub actions, you want to use the checkout to kind of make a copy of your content into this kind of empty machine. And in addition to checkout, there are many other script or templates you can use. And this is stored in this GitHub marketplace. So marketplace is like kind of similar to a big place where people store a lot of applications, but in this case, it's the templates for the workflows. So this window will show up if you click on edit the file on GitHub. This will show up on the side. And if you know the name of the script, you can just search and then it will pop up to the top. So I just want to mention this kind of convenient way of looking for a template in the marketplace. Of course, you need to know what's available, but that's a separate, more advanced topic that I will not talk about today. Just want to mention the existence so that you can check it out. Another interesting and useful syntax for writing the actions is to use the matrix. Sometimes you want to test a combination of different conditions, right? For example, in this case, and this hypothetical case, I have a program to test, and the program is written in Python or any other language, R or whatever language. And suppose I want to test the program, my program in the repository against different Python versions. And also there's a package, it's a Python package called NumPy for numerical computing. And suppose I also want to check against different version of NumPy, right? So you have 2 Python version, you have 2 NumPy version. So you have a full combination of this. And you can have more Python version and more NumPy versions. And to write it up, you have to expand this into like 4 different combinations. But this matrix syntax provide a compact way of expressing all of these combinations by just listing the versions, and then you can now use the syntax. So this is called matrix. So you have a different parameters here. So matrix dot Python version, which this is the Python version, and there's a matrix dot NumPy version. This is the NumPy version. This is the name that you put in. You can put any arbitrary name here, as long as you use the same name in the matrix listing and also in your this variable retrieving. Then if you write in this way, the system will automatically loop through all of the combinations, right? So this is a compact way of testing a lot of conditions. So you can basically list multiple conditions here, and you can have more items here, and the system will come up with all combinations. For example, you can have another row indicating, say, Mac OS and Linux, different operating system, and different versions and different package versions and so on. The system will loop through all of this, and the end result will be generated in the action tab. And let's just take a look quick. Now we have a good idea what this look like. So there's another repository I prepared for you to play with. You want to make a clone, you can clone. If you don't know how to clone this, just click on this fork. After you log into your GitHub, click on fork, it will make a copy into your GitHub repository, GitHub account. So this one has only one file under workflow. And this file use the YAML file, use the matrix syntax, right? So 2x2 combination. So 4 different conditions. And the rest is basically, I want to print out the Python and NumPy versions, and I'm going to do a pip install. So pip is a program in the Python world, install a certain package, right? So in this case, I'm going to install a certain NumPy version, and the version equals to one of the listed ones I list here. And the pip is coming from the Python, and the Python is coming from one of the 2 versions, right? So by writing this shell script, it will automatically run through all of the 4 combinations. And to see, when you see the result, there's only one workflow because we only have one YAML file. In that workflow, you will have 4 different jobs, right? Although this time we didn't specify explicitly 4 jobs, but it run through all the combinations, right? 2 different Python versions, 3.7 and 3.9, and 2 different NumPy versions, right? So all of the 4 are tested. And for each one of them, you can click on each one of them and you can see the result. And because we have the line in the YAML file to print out the names, the version names, so we said this is a 3.7.1.19. It's also indicated here, but this is a printed out from our YAML file. And the messages are pretty long, but you see that we are installing NumPy from 1.19, right? So this is a NumPy. And if you look at the logs from others, you will see a different version of Python and NumPy. So, and of course, in this case, I'm doing nothing. The script is very simple. Just print out the Python version and the NumPy version. But essentially, this indicates that you can actually put very complex testing routines in this Python example, right? And of course, the system allows you to run essentially arbitrary code. So it doesn't have to be Python. You can run R, you can run whatever software you have. You may not be able to run the licensed commercial software, but if you are working with like open source tools, it's very convenient to run whatever test you want to run manually. You just set it up once, and then it will automatically run every time you check in new changes. So that's our example number 2. And just to show you this compact syntax. Otherwise, the idea is the same as the previous ones. So in one of our demo, we briefly show the kind of the CPU type and all that. So this is coming from the GitHub page. Original link is here. You see that the hardware is actually quite good, right? And the reason I want to show this hardware and memory size is that you can actually run quite a bit of testing on this hardware, right? You can see 2-core CPU and 7 GB of RAM. This may be bigger than some of your small laptops, and you have 14 gigs of SSDs, right? So yeah, you cannot do a lot of data processing here, but it's probably good for running all the tests. And you can also run on the Mac OS, and it has a slightly different specs, but it's possible to test on the OS, on the Apple operating system. In terms of the operating system support on the GitHub Actions, you can see that Linux is Ubuntu, Mac, and Windows. Right? You can, if you are testing something on Windows, there are, I think, 2 different environments you can actually test. So it's pretty good to cover all of the operating systems. Okay, so that was GitHub Actions on github.com. And so the rest of the talk, and we can go pretty quickly here, along the same ideas, but there are other services, like I mentioned earlier. So one is GitLab. So GitLab is another kind of popular website where people put in their codes. And on GitLab, it's called the GitLab CD and CICD. So this is kind of the name of their product, but essentially basically the same, similar to the GitHub Actions. And just to make a comment about GitHub Actions, so GitHub Actions can also do other things other than CI and CD. So CI and CD is one of the things in GitHub Actions. And GitLab CI/CD, this is specific for CI/CD purposes. And again, we are also going to use a YAML file, although for the GitLab, the YAML file is called the .gitlab CI YAML on the top level folder of your repository. And the YAML file is a YAML file, so the format looks similar, but the syntax is different from GitHub Actions. And so in this simple example, I'm going to use an image of Python 3.5. So by default, this is an image of a Linux system with Python 3.5 pre-installed, right? And of course, you can specify a different version if you like, but this will simplify the process. So once you have the image, you are sure that Python 3.5 is available. So on the image, once this CDCI has started, I'm going to kind of print out the Python version, and I'm going to make a folder. I'm going to copy the file. So this is a file from my repository into a public folder. And this public folder will be kept after the CDCI has completed. And this is some detail to do with the syntax of the GitLab CDCI. So you can find out more information on the GitLab CDCI documentation. Here, I just want to show you the main ideas. So main idea is similar to GitHub Actions, just a slight syntax difference. I want to show you what it looks like. So interface is a little bit different. So here I am in my browser again. I am going to see, so this is my CI test 1 repository. And so here I have two files, right? So it's a very simple repository. Like I mentioned, the CDCI process is defined in this file. It has to be called .gitlab.ci.yaml, right? So because when you check in your repository into GitLab, if the system discovers this file, this is a special file with a special name, the system will know that, okay, you define your CDCI in this file, right? If you change the file name, then there will be no action because the system will consider there's no CDCI script in your repository. So like I said, this is the kind of a simple description of what needs to be done. And so essentially this will run on a Python system. It will copy a file to public and then come out. And so for this particular one, it's essentially just basically a hello world, print hello world into a website, right? So nothing too exciting. And so to see the CDCI actions in the GitLab system interface, you see there's a CDCI tab here. And so inside this, there's something called pipeline. So pipeline is the place to see your CDCI process. For example, suppose I'm going to see the past CDCI results, right? So this is now the interface is kind of similar to what you see in GitLab Actions, right? And for example, suppose you want to start the pipeline or the CDCI process, you can, for the GitLab, you can either actually do a push to your repository, or you can directly run the pipeline, right? So, and it will take some time to run. So I'm not going to run it here. But if you click on runtime here, we are not going to wait for the thing to complete. And you will see that it will start the process. And the process seems to be much slower than GitHub, but you see that it is doing something. It's launching the Docker, this is a container facility for image Python 3.5 and so on, right? So I'm not going to wait, but you see that it will run through your CDCI process defined in your YAML file, right? And of course, this is trivial. You can write much more complex process into the CDCI YAML file. The third service I want to mention is this Travis CI. So the website is travisci.com. So this was one of the early kind of service to support CD and CI. And I think some of the kind of established software projects are still maintained on Travis CI. The Travis CI, you follow the same ideas, and then you put your CDCI actions in a file name called travisci.yaml, with a dot in front of it. So same ideas and similar YAML format, but the syntax is slightly different. The main point I want to make here is that the main difference between Travis CI and the GitLab and GitHub action is that since Travis CI is an independent company, right, it's an independent website external to GitLab or GitHub. So there is one complexity here. So when you use a Travis CI to run the CDCI test on your GitHub repository, the Travis CI needs to pull your data from GitHub into Travis CI. Remember that the CDCI always has to make a copy of your repository to somewhere else. For the GitLab and GitHub, because you are doing it within the same website, you just need to check out your repository. Right? In GitHub case, we use the checkout facility. In GitLab, by default, is checkout. For Travis, you need to enable GitHub to let Travis to pull your data from GitHub, right? Because maybe your repository is private. So your Travis account needs to get the permission from your GitHub account to get your data. Once you run your CDCI process, maybe you need to push your data back to GitHub, right, to show the results or to show something. So this push, since you are pushing data from an external site into GitHub, you need to authenticate this push action. Right? So the complexity here is that you need to have some setup on the GitHub side to allow Travis to do these actions, because these two are two different companies or two different entities, right? So some external activities to go in and out of GitHub, you need some kind of authentication process set up. And that is not too difficult to set up. And I am not going to go into a lot of details. All of the details are in the supplementary material that I'm going to send you after the talk. But just to mention that on the GitHub side, you are going to generate access token. Right? Access token is like, if you don't know what this is like you can think of this as some kind of secret password, very long secret password. And it's basically a long string of random characters. Then you copy these random characters, you put into your Travis account for that project, right? For example, I have a particular repository on GitHub I want to run my CDCI against. So for that particular project, I generate a token and I put this token into this. For security reason, they are going to hide all of this. But if you do it once it will be set up. Now, this random string, you cannot see it once you create it for security reasons, but that is stored in the environment variable GitHub token, right? And then inside your Travis CI YAML file, you are going to provide this token. You see this $ GitHub token is an environment variable, but the value is the secret token you set up. And the secret because, I mean, this action, you don't want any outside parties to know what you are doing between the two sides, right? Because the communication is supposed to be secure. So once you have this, then your Travis CI/CD actions can now access your GitHub repositories, right? And you have to do the similar things on GitLab if you set up between Travis and GitLab. But this is the example to set up on GitHub and Travis. And it looks complicated, but basically just create a token, copy it over, and then use the variable. And that's simple. And so we can look at, so here I am at my GitHub repository, right? And we are not going to the details, but I want to show you the kind of overall flow. In this repository, we have a bunch of files, and you don't need to pay attention to the files, to other files. We have this travis.yaml file, right? And if you look closely, you notice that this one doesn't have the GitHub workflow folder, right? When it doesn't have the GitHub workflow folder, it will not trigger any actions on GitHub. But this folder, this repository has a Travis YAML file, right? So the Travis YAML file is just one file sitting on GitHub. It means nothing in GitHub. Right? GitHub won't trigger any actions because it's not the GitHub actions, but the file is sitting here. But then on Travis side, so this is a file in Travis YAML file format. I'm running, and you kind of see the same kind of flavor like a YAML, our other YAML file. You define the language, you define when the CDCI will be triggered, you define certain version of your package you want to use. You want to add additional packages to your kind of initial image, right? Because in this case, I'm going to run LaTeX on my data, and my initial Ubuntu image doesn't have the LaTeX, so you have to install LaTeX. You have to install additional packages, and you have to do the initial additional Python installation. So basically, all of these steps are to set up the image to be able to run my test. So all my test is written into this run.sh, right? So this can be a very complex script, and I just execute it inside my workflow. And then after the run, I do a bunch of other things. I copy things here and there and to display to a website and so on, right? So this is kind of overall picture. So I set up the environment, run the test, and then do whatever you need to do. And this file doesn't do anything on GitHub because it's not a GitHub action, but it's just a one file. But when you pull this file into Travis, so this is the Travis interface. And if you look at this particular project, when you pull this into Travis, and Travis will recognize that particular Travis YAML file, and then Travis will trigger that actions, right? And again, the output is pretty long, but then it will show you the system information. It will set up the initial image. And this is doing a lot of installation, like on and on, because I did a lot of package installation, right? So it transfers a lot of files, and it's too long to read here. But essentially, it will run through the whatever process you define in that YAML file, and then get the job done. The final results, the final results will be displayed here, right? So if you look at the link here, so you see that this is a link to the Travis, my account on Travis associated with one particular project, repository, and so on. And this is the branch master, right? So, and that status, since the Travis build was successful, it will show a passing here, right? Meaning that this has passed the CDCI testing on Travis, right? So that's kind of the overall picture of, so you see that we always set up the YAML file in the repository, and depending on which kind you want, and you can actually put all different format into the same repository, because when GitHub see the Travis or GitLab YAML file, it does nothing, right? It just doesn't recognize the format. Only when you have GitHub actions, and the GitHub website will react to it. And the same thing applies to different other services. Okay, so we look at the GitHub actions and briefly GitLab and Travis CI. So these three seems to be the kind of the popular ones, but there are also other popular ones. So another one a lot of people use is just Jenkins. Personally, I have not used Jenkins, but this is used by a lot of software packages. And there is Azure pipelines. I put the website links here. So if you are interested, or you know you are in your community, people use them, then you may check it out. The ideas are the same, and the syntax might be different. But the same ideas is that you automate a lot of testing or build process by writing them into the CDCI script, the YAML file. Right, so essentially, although the CDCI was initially originally invented for software development process, we find that it's also very useful for computational data research purposes. Right, you're writing papers, writing script, and you put these days you are supposed to put your things into the version control system. Initially, if you are a beginner of using version control, it may seem a little bit tedious, but over time, the benefits will outweigh the trouble. And also, CDCI is naturally integrated with version control system, right? That's why GitHub has a built-in CDCI process. GitLab also has its own, and Travis supports kind of different hosting services. So, and we have seen very simple examples, and hopefully we can show you the flavor how to do this, and you can look into more details to have a custom CDCI setup for your purposes. Different services use the different YAML files, and they can put all of them. If suppose you want to have the same repository that is supporting different CDCI, you can put all of them into one repository, and then depending on where you put your repository, different action will be triggered. And I want to mention that all of the materials in these slides are actually put into a website form, and the link is in the slides I'm going to send you. And this website, so this contains some of the details that I just mentioned verbally. So if you want to go back to find out more details, this is probably the place. And there's some additional kind of screenshots that I kind of went through earlier, but then maybe you didn't capture, may or may not capture. So the link is there, and then the link is here. And I'm going to send you the link to the slides after the presentation. And so I'm going to end the presentation here, and then I'm going to stop the recording, but then I'll be happy to take questions if there are any questions.